All right, today we're talking about trigonometric ratios, section 8.2. We are starting into the trig functions. You will probably want to have a calculator available and handy. We did find out that phone calculators do work if you tilt it sideways. The trig functions are on there. Don't know if that one will work.
Did you guys just find this out?
What?
Like that you can turn it sideways?
No, but
Okay.
I didn't know if it had to have the trig functions on it.
Wait, what are the
Okay, I was confused. Like, if
I'll
it
show you.
Just fit,
Yeah.
I was like, you
Wait,
just
is there an
read
app?
it.
it's just the standard calculator.
Go to standard calculator. Might be. So trigonometric ratios say section 8.2. If there is one word and one word only that you ever remembered from geometry, I'd probably want you to remember this one word. And that word is SOHCAHTOA. SOHCAHTOA. It is an acronym. Okay, it is an acronym for what is or what are the trigonometric ratios. Now, if you see, I say it all in one word, but really it's kind of broken up into three. You have SOHCAHTOA. There are three different parts here. And they are the ratios that are used within a right triangle to solve. Now, if you ever look, now a lot of times you look in a calculator, and you're probably like, man, what is this sin button? What is this cos button? What is this tan button? Has anybody ever thought that before? Like you look at it and you're like, what are these buttons mean? That's what we're talking about today. Okay? Sin is not sin. That's actually sine. Okay? That is pronounced as sine. This is how you spell it. That is sine. Alright? Sine is represented as the opposite over the hypotenuse. So S-O-H. Henceforth, why we call out so. Sine is the opposite over the hypotenuse. So for instance here, we are talking about angle A. In all of this, we are talking about angle A here. So if you look at angle A, we're looking at the opposite side. Well, 4. So I have 4. Over the hypotenuse, 5. That's where I get the ratio 4/5. It's the opposite side over the hypotenuse. Next, we have cosine. Cos stands for cosine. Cosine is the adjacent over the hypotenuse. Now, adjacent, when we think of the word adjacent, we think of the thing that is right next to. Okay, think about that back in... we talked about parallel lines, angles and parallel lines. We talked about adjacent angles, angles that were next to each other. In this term, the adjacent leg is the leg that is immediately next to A. So for example here, the leg right next to it is 3 over the hypotenuse, 5. So that's what gets us the K. So, sine, opposite over hypotenuse, K, cosine, adjacent over hypotenuse. And then lastly, we have the TOA. The TOA, that is our tangent. TOA stands for tangent, or tan stands for tangent. The tangent is the opposite over the adjacent. So again, that is the opposite over the adjacent. And all of these are ratios of the side lengths. Okay, all of these are ratios of the side lengths. And that's what we're going to be focusing in on today, is we're going to be finding the trig ratios and trig functions. Okay. Again, if there is one word to remember here, it is the word SOHCAHTOA. This is a big thing not only on NISA tests for the 11th graders, juniors in here, but also the ACT. Anybody plans to take the ACT, go to college, those type of things? This is a big thing that is on the ACT. There's a lot of this on it. I remember some of you came in after taking the map test, and somebody's like, what's this sine, cosine, tangent stuff? That's this stuff. It's on there a lot. It's very popular. If you go take trig later on with Ms. Fendel, you'll need to know then as well. But sine, cosine, tangent. Again, a lot of times when we're doing this, write SOHCAHTOA at the top of your page just so you can see it every single time. All right? So, let's look at the first problem here. I want to write each trigonometric ratio as a fraction and as a decimal rounded to the nearest hundredth. Okay. The first thing, number one, it says I want to find the sine of K. So I am talking about angle K. I'm talking about sine. So sine is my So I am looking at the opposite over hypotenuse. Does everybody understand opposite over hypotenuse? So, S-O-H. I'm looking at opposite over hypotenuse. So K. What is the opposite side of K? I look across. The opposite side is 15. And then I look. What is my hypotenuse? I have a right triangle here. Which one is my hypotenuse? 17. So the sine of angle K is 15 over 17. And then I'm going to use the calculator and round that to the nearest hundredth. What is that rounded to the nearest hundredth? Anybody? Was it? 0.88. Nice job. And that is the sine of angle K. Next. Number 2 says I want to find the cosine of angle H. So here's angle H. Now I want to find the cosine. That is my ka. What does the A stand for? A stands for the adjacent. Adjacent means right next to it. Which angle is right, or which side is right next to H? 15. Over, what's my hypotenuse? 17. And what is that as a decimal then? Approximately 0.88. Nice job.
Okay, but how did you have 17 then?
What?
Like, can you have 17, or do you always go for the smallest number?
I have to go in the correct order.
Okay.
So this one was adjacent first and then hypotenuse.
Okay.
So it'd be adjacent over hypotenuse. Yep, I don't want to put hypotenuse over anything. Does that make sense? Was that your question?
Well, like, which side would you choose first to go? Never mind. Just
Go in the order. So like adjacent comes first, that goes on top. Okay. Number 3. It wants me to find the cosine of K. So here's angle K. I want to find the cosine of angle K. What is the cosine again? I want the adjacent over the hypotenuse. Which one is right next to K? 8. 8 over, what's my hypotenuse? 17. And that is approximately, 8 over 17 is approximately 0.47. Nice job. And then the very last one. I want to find the tangent of angle H. Tangent is my TOA, T-O-A. That stands for opposite over adjacent. So I'm at H, so I want the opposite over the adjacent. What is my ratio for number 4 going to be, Tech? 8 over 15. And that is approximately what then, Nathan?
0.53 repeating.
0.53. And those are the trig ratios. Again, you will want to make sure you have SOHCAHTOA written down somewhere.
When we hit the ratio equal to, or on the other side.
Yes. All right. Next thing we're going to talk about here is we're actually going to use our calculator to estimate these. Okay, so you can use a calculator to find the value of the trigonometric ratios. For example, if you hit the cosine button followed by 38 and hit enter, you would get something that is approximately 0.79. Again, some of your calculators are different. Make sure you can find these functions. We're going to be working with them. And then along with that, we can use the sine, cosine, tangent functions to solve for the missing side lengths within a right triangle. For example, I know that cosine represents the adjacent over hypotenuse. We all know that by now, right? Cosine is adjacent over hypotenuse. Well, if I know the cosine of an angle and I know one of these side lengths, I can use cosine to solve for the other side lengths. Essentially, this is the same problem as warm-up number 1. The only difference was I gave you the numbers. You have to find the cosine or sine. That is the only difference between what we're going to be doing and the warm-up you did on number 1. Okay? You just have to find the decimal first. Otherwise, these are about the exact same problems. Okay? So let's look at one of these. Use your calculator to find each trigonometric ratio, round to the nearest hundredth. So take a couple seconds using your calculator, find the sine, cosine, and tangent buttons, and type those in. Round them to the nearest hundredth. All right, so let's look at these here. Number 9, the sine of 42. What, Dylan?